All right, good evening. This is live training from Unity Technologies, and this week we are going to be doing tips and tricks number 4. My name is Adam Buckner. I am one of the screencasters that we have here at Unity Technologies. So today should be a buffet, a smorgasbord of little things that I've pulled out of the grab bag, and had some suggestions from people as to what we could talk about today. And then at the end we will open it up for Q&A. I want to talk about Mathf, the Mathf function group. So let's just look at Mathf. Most people run into Mathf backwards. They're looking for a solution and they end up at Mathf. But I want to start at Mathf, which is a collection of common math functions. And I want to talk about some in specific today. We're going to talk about Lerp and we're going to talk about Perlin Noise. And then we'll move on to some other subjects. So Mathf, it's a collection of common math functions that are very, very useful. It comes up with some static variables like epsilon and infinity and pi. That's always very useful, but it's the static functions that I think are very, very important. We've bumped into a couple of these before. We've talked about clamp, which clamps a value between a minimum and a maximum value. So if you want to clamp something between the left and right of your screen, you can put in the current value at the left and the right of your screen, and it will go ahead and clamp that. You can also do rounds. You can round to int, you can do floor, and you can do ceiling. But I want to talk specifically about Lerp. Lerp interpolates between a and b by t, and t is clamped between 0 and 1. And the reason that I want to talk about Lerp is that Lerp, no offense to this particular page, I'm trying to get it updated a little bit. The explanation here is perfectly legal and perfectly legitimate, but it's also a little bit confusing. I also see quite a few people who have Lerp misusing Lerp, and either I'm not actually sure why. I think partly it's because that they're confused by the description. So what is Lerp? Lerp is a term for linear interpolation. In short, Lerp in Unity is for finding a desired value between two known values. We can find Lerp, as we can see here in the documentation. And if we do a search just for Lerp, just so you know, Lerp is also available in a whole bunch of other classes. You can Lerp between colors, you can Lerp between vectors at 2, 3, and 4. You can Lerp between materials. So you're interpolating between these two states. Your state A and your state B over T. One of the problems that we have when looking at the documentation is when you try to run this. So let's just quickly copy this. And let's create a new script. So let's create a C# script, and let's call this Lerp test. And let's go ahead and open that up in MonoDevelop. And then let's paste this in, Lerp test. I'm changing the name of the class because remember the name of the class has to also match the name of the script. This is going to move something between our minimum and our maximum over time. It's got a vector 3 position. It's finding the transform position of the object that we put it on. We're giving it a minimum and a maximum. And then we run our vector 3. We give it a Mathf Lerp. It's supposed to interpolate between minimum and maximum. So let's go ahead and just try this. So let's make we're using 4.5 today, so no context click. That'll confuse me. I'm used to using 6. So let's go ahead and reset that. And frame selected. So there's our cube. Let's add our Lerp test to the cube. Yay! You guys all right? Then let's save this. Let's save this as our main scene there. So we can save and play. We always want to save and play. And then we go and hit play. And then it's going to start up. And pow! It just looks like it's gone. Where the heck did it go? Let's find that. Let's quit and let's find that cube again. Let's back up. And even if we adjust this to 0 and 10, so it sort of starts where we want it to be. Long way around of showing the problem, and then we'll show the answer. Actually, that move, sometimes it takes more than that first second for the game to get started, that the cube just seems to slam over to its maximum or end position, and we don't see it actually lerping. And because the value we are using to interpolate between the minimum and maximum, or the beginning and end positions, is time.time, this means that the cube will move from from minimum to maximum within the value of 0 to 1, or within 1 second. And not just any 1 second, the very first second of the game. Using time.time as t, the cube just slams over to the edge. I guess my computer is actually fast enough, and people don't understand why we are running Lerp if it just simply seems to move from its start position to its end position at the moment that the game starts. So when a common case, as we're seeing here for moving Lerp, would be moving or animating something between our 2 points over time in a linear fashion. And so we have our known point A and our known point B, and we have control over our time. But I think that using time.time here is a bit wrong. And it's simplified because people are trying to come up with this very easy explanation. And so technically this code works, but I think time.time is wrong. So then a lot of people then try to put in time.delta time, and we'll talk about why this doesn't work either, because this will essentially just make your cube jiggle. What we need to be able to get this to work properly is we need a way for us to pick our start time. So I'm going to make this example a little bit more complicated. Let's do our start. Let's have a start and end. Let's move minimum and maximum to start and end. And then make it a little bit more obvious. I'm going to start at 0 and let's move it to 90. And don't forget that we can override these in the inspector. And then we want to have our transition speed, because we want to have a control over how fast this thing moves. So let's have and let's make that a float. Our float called transition speed. And then we also want to grab a start time. Now, in a proper example, we would set the start time by an event that happens in our script rather than just setting it as a hard number. But let's go ahead and give it a delay so that our scene can come up and run. So let's go ahead and just make this start after a second. And then in our update, let me just increase this just a little bit. Let's give a float, only if I learn how to type. Let's call it Lerp value. And that Lerp value is going to be equal to that Mathf Lerp that we have down here. I just want to separate this out so that we can see what we're doing. Mathf Lerp. Lerp, please. There we go. And we're going to give it start as our start point, and end as our end point. And as our time, we want it to be, as our t, the thing that we're calculating, we want it to be the time.time in the game, which we're going to use again, only if we get the right parentheses there, time.time, which is how the game is counting up. But we want it to be minus our start time. And this is important when we select, which we're not going to do in this example, when we select that start time with an event. So we want to, have our spaceship that's tumbling out of bounds suddenly correct itself on a vector 3, where we do a vector3.lerp. So when you hit that emergency button, to straighten up your spaceship, that'll be the start time that's set by the event in your game. And then we also want to multiply this by how about an R in there? Transition speed. So then we multiply that by our transition speed. And that will give us our position. And I'm not going to change position because it's going to be a little bit easier to watch if we do this with rotation. I also want to show that we can do this we can Lerp this for any value we want. And so that's going to be our transform, not rotation, our transform Euler angles. Is going to be equal to a new vector 3, and that's going to be our Lerp value, and then 0, 0. So let's save that, come back to Unity, pray to the compile gods, frame selected in on our cube, click cube, hit F, there we go, and make sure that our Lerp test is on. I'm going to reset this in case there was any values that were hanging over from our previous version of the script. So we can see that we're going to rotate between 0 degrees and 90 degrees, and we need to have a transition speed. So let's go ahead and give ourselves a transition speed of 0.5. So it's going to do this in half a second, and then our rotate time, our start time will happen in 1 second. And pretend that start time is some private value that we set. And we can see now it rotates evenly between that start value and that end value, and that we give it that time, that start time and the transition speed to get it to work. Now, misusing Lerp. People who misuse Lerp. Lerp is commonly misused in one particular way. It's often used, and I think because of this original code, it confuses people. I think many people assume that it's broken because we're using time.time. And to fix this supposedly broken example, people, from what I've talked to, have a tendency to try to use time.delta time in place of time.time. So let's look back at that script. And a common misuse example would be, and I'm going to just rewrite all this code, a public, a float, and then you'd have a destination. And then in our update, we would have our float, and we create a new float called, say, something like new position, only if I spell it correctly, new position X. And then we'd set that equal to our Mathf Lerp. Oh, Lerp, please. Our Mathf Lerp, and then it would be our transform, our current transform position, dot X. Our destination, where we're trying to get to, and then our time.delta time. This is what I see a lot of people using it for. And then, of course, we're going to set our transform position to a new vector 3. And that vector 3 is going to be made out of our new position on the X. And then let's just leave it there at origin on the other two for the example purposes. So 0 and 0. Now, this is common, and if we go ahead and we look at, let's get out of play mode. Let that compile, and let's give it a new destination of just, 2 in the X. And it seems to make this nice sort of smooth move. Let's go ahead and hit play again. Oh, that was in play mode, then I shoved that in. I must have hit play twice. So let's go ahead and make that 2 again. And hit play, and it moves. And it looks like, okay, it's a nice smooth move. And why can't I use this for this? It's sort of a dampening, a smooth, damp kind of way of using Lerp. Partly we should talk about why it works. And second of all, I want to talk about why it doesn't work. It's got an interesting effect. It's kind of easing or dampening the effect of the object's transition. But let's think about time.delta time. Time.delta time doesn't actually approach any number. It doesn't go from 0 towards 1, which is what our t is supposed to be doing. It's a fairly consistent value as long as our game is running at a consistent frame rate. And this means that each frame, the value of time.delta time will be hovering around the same value, near the same value. So if we weren't feeding the transition, if we weren't feeding the transform's position each frame into this line of code, Lerp would not move from any value to any value. It's just going to jiggle near a single value, a single point. So let's look back at trying that start and destination. So if we have our start here, let's just make another quick variable, public float start. And we have our destination. Let's just make that 5, just a little bit bigger. And we start with our new position X, and we do Mathf Lerp, but not with our transform position X to start with. Our new transform position X is going to be equal our start point, our destination, and our time.delta time. And so if we try this, it's just going to jiggle, depending upon what my computer is doing and how I'm processing, sending stuff to Twitch. It's not going anywhere because that time.delta time isn't changing. We could debug.log time.delta time, and it's just going to jiggle. That first example where we use time.delta time works, again, because each frame we're using our start point. Our start point is resetting the transform's current position. And so that means each frame the calculation is essentially restarted. And the smoothing and dampening feel comes from the fact that the destination doesn't change. So each frame, the test object is going to move sort of incrementally small values towards that destination. The danger that we have with this is that it's never going to ever reach its destination. If we take a look at that first example script again, just undo this a little bit. And save that, come back. Watch the values in position. And see, even after visibly it stops, these numbers up here in the upper right are going to keep bumping along. It conveniently went to 2. Sometimes if you're doing it for a long time, it'll run into some very, 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 very small numbers. It would never really reach its point until essentially the float values are exceeded and the computer has to round off that number. So if we want to use it, can we still use this Lerp for smooth dampening? Yes, we can, but we need to be aware of what we're doing. We can't just slam it raw and rude like we did, incrementally moving towards our direction. And I think the key here is knowing what we're doing, so that we know how we can break it. And I was going to say, isn't that important in life? Knowing where the rules are. And once you know what the rules are, you can know how to break them. So if we want to get this misused style of using Lerp to work, we need to do a couple of things. We need a threshold. So public float threshold. And let's set that to a small number, like 0.01. And then in our destination, let's just go ahead and set that here to 5. 5's good enough. And then in our update function, the first thing we want to check is to make sure if our transform's position x is not our destination. We want to make sure that if we're not at our destination, that we go ahead and check things out. So then inside that, if we've not reached our destination, then what we want to do is get our new position x from our Lerp transform position x, destination, and time.delta time. And then, so if we're not at our destination, we do our Lerp. And then if our destination minus our new position x, essentially the difference between our destination and our new proposed position is less than our threshold, then we want to say our new position x is the same as the destination. We have essentially reached our destination. So when we get to those really small numbers, we just go ahead and we set ourselves at our destination. Whoops, speaking of small numbers, we need a little f behind that 0.01. I'm just going to go ahead and skip the f behind the 5. And as one last little bit, let's go ahead and pop that up inside the if statement. So now we have a threshold of 0.01 and with an f, and we have our destination of 5. And then if our transform position x is not equal to our destination, then we create a new position x, which is going to be our Lerp between our transform position x, its destination, and time.delta time. So each frame we're going to creep a little bit closer to our destination. And then if our destination minus our new position x, so the difference between those two is less than the threshold, we just set our new position x to the destination. We have arrived. And then our transform position is equal to that new vector 3, transform position x 0, 0. So let's go ahead and save this, and let's come back to Unity. Frame selected. So let's frame selected, and then let's back out a little bit, and then let's hit our script. And we can see that it moves towards and it comes to a nice gliding stop, and then we set our value. If we wanted to change that value from 0.01, we could try it a little bit larger. We can try it a little bit of a larger value, but I think if we get much larger than 0.01, we'll see a pop right towards the end. So as we move towards it, I think it's going to pop. Bink, yeah, so you need to give it, you need to have that number small enough, but we don't want it to sort of creep down into the point where we don't want it, we want to keep that number small enough so that we don't see a pop, and yet we still go towards the end. So when we're here with Lerp, the other thing to look at when you're looking at Mathf is that Lerp is very important for doing some very specific and custom code, but there are also some built-in pieces that you can look at. Oh, also, I did want to point out the fact that you can not only do you have Lerp, but you have Lerp angle, so you can interpret between the angles. And you also have spherical linear interpolation called slurp, which we're not going to get into today. But I did want to talk about move towards. A lot of times when people are using Lerp, they're using Lerp when they could actually be using move towards. And move towards does a lot of the work that's inside a Lerp for you. And if you go ahead and read the description, essentially it's the same as Mathf Lerp, but instead the function will ensure that the speed will never exceed your max delta, and that the negative values of max delta pushes the value away from the target. And I think this is very useful for doing certain things like, what I think the example here is refilling the equivalent of a health bar. So if you had a current strength and you wanted to have, and you have a max strength and you have a recovery rate, that Mathf move towards is going to move you always through from your current strength towards your max strength. It's going to push you in that direction. And I had a little example I was going to pop up so we could do that. If we had... if you just imagine we were making a health bar, I don't really want to get into doing with UI stuff today, but I'm going to just do this with the position on a cube. So let's go ahead and make a plane. And I'm going to use this cube again. I'm going to pop it up a little ways. Let's pop in a light here as well. Let's just get a directional light going. And get a good looking side of that. And then let's create another C# script. And let's just do this one, move towards test. And pop that onto the cube. And then in our move towards test, I'm going to go ahead and sort of use this example. I'm going to go and grab this example bit here first. And paste that in. Move towards test. So we've got our current strength, our max strength, our recovery rate, and then we can, I would probably in start, I'm going to set my current strength to be equal to my max strength. And then in my input, my update, I'm going to do an input just so we can give ourselves some insta damage if the input is get mouse button down 0. So that first mouse button. Let's say our current strength minus equals, I don't know, 1. How about that? And then where we have our recovery rate underneath, and then we are going to set transform.local scale to a new vector 3. And that vector 3 is going to be 1 current strength. Equals. God, I'm just not doing it with it today. Equals current strength. Copy it. Current strength. 1. All right, and again, pray to the compile gods. Make sure that I've made a mistake. Oh no, I'm doing great today. Can I just go home? Yep, second one of those. We still have our Lerp test running. That's right. Okay, there we go. Bink. All right, so you click it a bunch of times and the health goes down. Now, this is supposed to be really simple. It's supposed to be a minute. And then we can see that it grows back up again. And we can see that that move towards is moving towards. You could have just done it by reading the code. We've got our current strength. You can watch the current strength come back up again. We can see our max strength. We've got our little cube. You take our damage. You know, this could be health. This could be anything you're recovering for. This is showing you why you don't need to use Lerp. Just use move towards. So the other thing I wanted to show you while we were here, and I want to move on to some other stuff. Perlin Noise. You can get, amongst all of the other things you can get in Mathf, you can also get noise. You can get Perlin Noise. And Perlin Noise is nice because it is not completely random. it is pseudo-random. And the float values, you can look at that picture, you can see it's a bit like a cloud, is that the values are always, to a certain degree, softly moving from one value to another value. Through, in this case, it's grayscale, it's moving through shades of gray between white and black. And one of the examples that I saw that someone had used this for was grabbing Perlin Noise to make a camera shake, because it wasn't as violent and random as using a random number, just using random.range or just picking a random value. And you can sample it pretty regularly, and you don't need to dampen or smooth between the values, because the values are dampened and smoothed inside the range that you get. And if we look at the description, it's 2D at this point. You're looking at rows and columns, but you can simply get a single value by just looking at essentially an X value. Here we have of 0, or pick a value that you want. So again, let's do another simple test. Let's call this Perlin Noise test. So let's go ahead and open our Perlin Noise test. So public, float, let's just call it value. I don't want to come up with anything interesting tonight. Let's grab a vector3 just out of convenience, because it's going to hold it. Another public vector. I don't care if it's, doesn't it be public or private. Just private's fine. Vector3, called offset. And then in start, I'm just using the offset just to get some random numbers. I'll explain what I'm doing here in a second. Offset is going to be equal to a new vector3, and that new vector3 is going to be a random range from -1 to 1. And this is just, it'll make sense as to, I'm sort of pushing the envelope again with this one. We don't really need it, but it kind of makes it fun. And then let's duplicate this a couple of times and get rid of that trailing comma. So essentially what I'm doing is I'm making a random range of -1 to 1 for X, Y, and Z. For our offset. And then in update, let's just grab 3 floats and just call them sample X. And that's going to be equal to Mathf, again, our wonderful Mathf, Perlin Noise. And what we're going to grab here, because we want that number to change, we're going to use our time.time. So this number will continue to increment up as our game continues. And we could use 0 or whatever. Let's actually start off with 0 here, and we'll see how this works. I'm going to start off with 0 here. So that's my sample X, and I'm going to copy this, and let's get sample Y and sample Z. So I've got 3 samples now of Perlin Noise. And let's take our camera, .main. So this is grabbing the main camera. There's a little shorthand for grabbing the main camera. And let's grab its background color. And let's make that equal to a new color. That's going to be sample X, sample Y, and sample Z. Save this. Come back to Unity and find out what I've done wrong again. Oh, in my funny little shorthand, I forgot the semicolon at the end of that. So yes, that is my stretched out statement has been shoved into a column. That should be fine. Good. Yes, we know offset hasn't been used. Let's go ahead and put that on any object. It could be the plane, because it's going to find the camera.main. Could put it on the camera. Let's save this. Let's go ahead and hit play. And we can see how that's grabbing random values. And they're relatively soft. They're lerped already. They're moving back and forth through that range that we're seeing. It's gray because we're asking it for the same value. Because we're using time.time for the same sample, and our offset is the same. So if we look at what we're doing with that picture, we're dragging through a single line of pixels through this. And so that's going to return that same value for each one. Now, if we were to use our samples here, not our sample, but our offset. So offset X. Actually, let's do it this way. And our offset Y. And our offset Z. Now, so this is going to be whoops, Z, please. So this is going to be random numbers. So we're going to pick random numbers relatively close to each other, but random sort of slices through whatever the image that it's going to create. And when we come back to Unity, and thank the compile gods, I did sacrifice a small animal, and so I didn't make a mistake. It's still gray. It's not supposed to be. Okay. Maybe they need to be bigger. 10. Because if the numbers are relatively close together, they are going to be gray. Now, I thought that 1 would be big enough. So we have to make a large enough difference so that those points diverge from each other. We can use this value as well. It wasn't really what I was going to use it for. Let me just do this to set these farther off. Time.time, divided by value times value. So this is just giving us public float 5. The larger the difference between these values, and you see now it's really poppy because our values are relatively far apart. This is the other thing I want to show you. The farther you get your values apart, the less smooth it's going to be, because the RGB values that we're dealing with are going to be farther away from each other. So therefore, it's going to appear more random, and the numbers as they're offset are going to create a more varied RGB color that you're going to get. Because the difference between those three are going to diverge quite a bit. We can just, why don't we set this, this is what I was going to do, so copy this. We can just set this to value. Oh, come on. Save that, back to Unity. Got our value of 5. Let's see how that works for diverging. Not too bad. So you could fuss around with this value and how far apart you wanted these things to be. So you're picking this random number, but the random number is something that smoothly moves in its value. Camera shake. Changing the color of the background of your camera. So, Perlin Noise, Mathf. I'm going to move on from Mathf. I've been so successful with it so far. I was going to talk about aligning game objects and vertex snapping. Vertex snapping and aligning game objects. Let's look at this. First of all, hotkeys. A lot of people don't know that this is here. The one I want to talk about specifically is this one. Not that one, that one. And there's some other very useful tools for quickly moving game objects around in the scene. And they have to do a lot with this page, which is positioning game objects. Often these pages are overlooked because they're relatively simple. People scan them and think, I can translate, rotate, and scale. They might already know about using the F key for frame selected and the double F key to follow a game object in the scene. We've covered that in other sessions. Gizmo, toggle displays, but unit snapping. This is the thing I want to talk about, is unit snapping, surface snapping, and lookout rotation, because these are often missed and passed over. To set this, you have control over the snapping by going into the snap settings. Let me do that again a little bit more slowly. By going into the snap settings, it's edit snap settings. And inside the snap settings, you can set your units, which are default to 1, and you can set your scale as well. And what snapping, the base snapping does, is when you have an object, you can move it around in the scene. If you hold the Control key on Windows or the Command key on Mac, it will snap exactly 1 additional unit from wherever it was. So let's just sort of move these into a new location. You can see that if you look at the transform position up in the upper left, they're all completely, not random numbers, but they've got, they're not evenly snapped to the grid. And if I hold down, in my case, the Command key because I'm on a Mac, Control key for Windows, you can see that when I snap it, it snaps at exactly 1 unit because that's what I have set up in my snap settings. And it'll be 1 unit from its current position. And if I want to snap it back to the grid, I use these buttons back here. So I can snap any one of the axes to the grid, or if it's completely off, I can snap all axes to the closest grid point. Vertex snapping will allow us, when we hold down the V key, I'm holding down the V key and moving the V key and moving the mouse, and we can see that it is putting the transform translate gizmo over one of the 8 vertices that we have here on the cube. And if I click on it, it will allow me to move to avert a vertex on another object. In this case, we've got a plane, and the reason I used a plane, not a quad, is because we have a lot of these small 1x quads on making up the plane. So I can snap the cube to any one of these vertices by simply clicking and dragging. Now, there is another useful tool with a set of hotkeys, and that's surface snapping. If we hold down the Shift key, and in my case, along with the Command key on the Mac or the Control key on Windows, the game object we are manipulating will be snapped to the surface of the object below it. You can see that it's snapping it to the surface. So if I'm up here and then I move it, you can see how I've snapped it down to that surface. So if I've got my treasure chest and I'm in my dungeon, I can just drag that thing, that cube. Here we go. There's our cube. That cube is a treasure chest. It's a prefab. Drag it into the scene. Hold down the Command and the Shift key, and it's going to snap to that ground surface. And so it's going to align it perfectly. I don't have to get really fiddly about it. I can just snap it. The other thing that you can do with these, using another key combination, or the same key combination in another tool, let me go ahead and stretch this out on the Z-axis so we can see that it's long and thin down the Z. And then I go into my rotational tool, and I can rotate my cube, grab it by the middle to free rotate, or I can grab the axes and do a single axis rotation. But if I click on one of these axes or the middle and have the Command and Shift key down and hit a surface, I am looking at the point where my mouse is touching the collider. So if you want something to rotate towards something, so I can point something at it, and this is true for a light as well, is any game object. So if I want to point my light at something, so let me reset this. Bink, and then let's just move this up. Yep. And then I create, let's get rid of my directional light, and then I create a spotlight. And translate, just lift it up so we can see it. And then frame selected. And then I can go into my rotate tool, Command and Shift, and I can spot it onto whatever surface I want the spotlight to shine onto. So it's very useful. If I can, when I'm doing that, you have to make sure you're in drag mode and then drag it onto it. It'll follow the cursor onto whatever it is that you want to shine it on. Now, speaking of our prefabs, let me put that directional light back on because it's a little bit more interesting. if we had something, which is what I was working on, when that failed, I was going to bring in a little race game with some track that we could zip together, but I'm not going to. I'm going to put some cubes together. So that, again, that vertex snapping bit where you can also then duplicate your game objects, and then remember the V key. Hold down that V key when you're in translate mode. Come on, you can do it. And then you can start, snapping them around, and you can start to build. V key, please. You could snap those out, and so you can build your if you had modular game objects, if you had a track that you wanted to build. And these are things that, especially when you're dealing with odd sizes, so if you've got strange scales, and you can't deal with snapping things using the grid. We talked about that earlier, where we're snapping the grid. You've got some things with some odd scales, and you want them to snap up. It's going to be really, really hard to get the vertices to snap up if you aren't using, in translate mode, the vertex snapping to get to an object. All right, let's pick the upper one. There we go. And just as we're finishing up, game object, move to view, align to view, and align view to selected. Also very important and useful when you're placing your objects in your scene. So if you want to look at something, you can, and you don't know where you are in the scene, you can frame select it on it. You can also bring it to you. So you can bring that game object to you if you grab it. Game object. It should move to our view. Or we should move to it. Well. Well, blow me down. I'll give up on today. We know frame selected, but we should also, well, we can align with view, and it should come to us. So there's us. Oh, I know why. It's because I had my focus on the object. And what a move to view does is it moves it to where your focus point is. And even though I had moved very far away, I was still focused on the object itself. So let me move that. So it wasn't moving. So move to view. There it is. It's at where my viewpoint is. There's this point in front of the scene view camera, and that's where the move to view happens. So if you're in your dungeon and you want to move an object to where you're working, just grab it, hit move to view, and it'll pop to where you are. Cool. Well, let's go into Q&A. Schellenberg, HQ. I think I have the answer to what you're doing. I'm not completely back reading, but are you asking, can you test networking between what's in the editor and a standalone build? And the answer is yes. It's been a while since I've done it, but you can create a standalone build or a web build or an iOS build, and you can run the editor and you can test between the editor and your build. There were some issues that you have to, which are an easy workaround, and I just can't remember what they are, where you can't have too many items on the same IP address talking to each other without getting some sort of conflict. And I remembered it was two. I could run an iOS device. I could run a standalone build and a web player, or a standalone build and the editor, but I couldn't run the standalone build, an editor, and a web player on the same machine without having some conflict. And I haven't done it in about 2 years, so I don't remember what the conflict was. And sadly, I'd pop it up and let you look at it, but it was a version 3 project, and I don't think it survived several upgrades, including UI. I was using Easy GUI at the time, and I haven't updated EasyGUI to the point where it runs in the current version of Unity. So the last time I opened the project, it was full of errors that I hadn't fixed. Otherwise, I'd actually run you through it and show you that you can do that. But I can't. Sorry. The other thing, and I see that you've mentioned Photon, is that I was using the built-in Unity networking from version 3. And there have been some updates to it in version 4, and also there's going to be some massive updates to networking in version 5. Why don't I go ahead and see if I can grab that URL. Unity networking 5. Let's see what we can find from blogs. This may be worth reading about because from what I saw, what I'm going to get to is the Unite, if I can get the Unite video, where they make a multiplayer game in the 40 minutes of the session. Networking 5 on YouTube, yep. And so this is all definitely worth...
So hello, welcome to the...
Stop, please. Worth a look. No, I'm not going to show you the stream of the stream. I'm just giving you the URL of the stream. If I could do it. Yeah, Tavaza, I actually found that Unity networking was very powerful, but it was very low level, and you really needed to know what you were doing with low level networking. And so I would often recommend some of the third-party networking packages that people have done, which essentially give a high-level access to the low-level networking. Unity 5 is going to be both, where they've reworked the low-level networking, and they've also created a high-level API on it that makes it far easier to use. Definitely look at that YouTube link and see how quickly they make a little networked multiplayer game. Copperfield asks, on physics, if I have a rigid body not set to kinematic, but want to rotate it around the Z-axis manually, can I do that without setting it kinematic from a script? Well, you don't have to set it kinematic from a script, and you probably wouldn't set it kinematic from a script unless you had to. Let's take a look at this, but let's create a new cube, just because the other one's a prefab. Let me just turn these off. So we've got our cube here, and it's got a collider. So you can set your rigid body. So definitely, if you have a collider and you want to move it, you can, if this is just a box and someone's going to bump into it, leave it the way it is, doesn't need anything else. If you are going to move this collider in any way, you first need to have a physics rigid body attached. And this is pretty much true going into 5 as well. And then you want to say it's a kinematic rigid body if you don't want physics to, the physics forces to interact with it. So if I was going to make actually any of these tests that we've done, which move or rotate the cube, I would want to have a rigid body attached, and I would want to then make it is kinematic, because if it isn't is kinematic, you know, you can turn gravity off, but essentially it's going to start behaving. You can bump into it, you can push it around. When it is kinematic, you can move it. It won't trigger the rebuild of the cache, but it won't take up that performance hit, and you can go ahead and move it with the script, and it won't be moved by forces in the game. Rawansulf is asking, I'm just a beginner and I want to get a general view on how to make a game suitable for Android. The main thing about making a touch game, I think, is primarily rethinking the way that you do input. We do have some pre-made input scripts that you can get in the sample assets on the asset store. So if you come to asset store and you ask for sample assets, so it's a little bit slow because don't forget I've got lots of stuff going on today. Sample assets, and there will be some 2D scripts going on in here as well for 2D input. I believe there's some joystick scripts and some other things. But a good example of a game that works well, it's not us. This is not a Unity game, but I think it's a very good example of using limited input for having a reasonable good game that is very successful. World of Tanks Blitz. I want to see if there's a picture of the interface. Yeah. see if I can find another one. Go ahead and push through, because this is don't want to spend too much time on an example that 400 by 300. Oh, that one's not so bad. So this one works, if you imagine, with your hands holding the back of the device and 2 thumbs. So there's your move. This side is utilities. This is a communications menu. That is a zoom menu. That's the fire. There's also an optional fire here. And this is, I think, an older version of the interface, or it's been customized because no, maybe not. And then over here, you've got some utilities. So you can actively pick all of the important things to do in this game with 2 thumbs. And the game and gameplay only requires 2 thumbs at any one time, and you don't ever feel that you're really missing out on your control scheme. One of the biggest things that I find that people, when they first come to mobile gaming, is they try to do something too complicated for the interface. And the 2 things that you're missing is that holding the device takes more fingers than manipulating the device. And there is no tactile feedback through the device. It's just a flat plane of glass. So it's hard to know if you've missed a button. It's hard to know if you've pulled your finger off the button. You can't really design a game where your eyes are on the screen, but you're not paying attention to your keyboard. Also, typing any content into the keyboard is more difficult, even on large devices like an iPad or a tablet. So I'd say the first thing is limit your UI and your gameplay to understand that UI. And I think the next thing is then just make sure you're aware of the device's limitations. Though they're very powerful now, they still are more limited compared to even a browser game. Dangly Neuron is asking, are there any good tutorials on basic Mechanim? And please, not the character animations, but basic animations like turrets and tanks. It's an interesting question because I'm not sure how I would approach it. I would have a tendency to approach at least turrets on a tank using mechanical scripting rather than animation. Can you, and I'll look at the bottom, can you give me a description more of how you're approaching this with animations? Because I would imagine if I was a tank, like World of Tanks, I would have the turret being a separate game object with its own transform that I was manipulating within the physical bounds, parented to the tank body model. And certainly World of Tanks has certain things where that allows the tank underneath to move independently of the turret. But I wouldn't be using Mechanim for that. The closest example of non-character animation stuff for Mechanim, I would actually say, is look at Animate Anything, which is a session I did a little while ago. Animate Anything with Mechanim. And this just shows a very basic approach. We animate turning on lights and opening doors, how you'd approach an animation that with nothing to do with characters. Toxic Bite asks, can you show 2 separate camera views, like a mini-map in real time and bird perspective and the player camera? Basically, yes. You've got the main camera. That's going to just look at our game. You need a second camera. Create camera. And can we rearrange these? I never remember what version I'm in. Oh, I can. Yes, I just want to put them together. So let's call this our other camera. That's our other camera. And it's going to look at something else. And what you use is clear flags. And you're going to use your depth, your rendering depth. You're also going to be using layers. So the background, our main camera, is going to look at our skybox or our solid color. In its culling mask is what is it going to look at. Right now we have everything. We could create a new layer and put something particular on it, which we may just do. And then we have our second camera. And then we want it to clear on depth only. And then let's give it a depth of 1, because it's going to start with lower numbers and move up. So our main camera started with a depth of -1. Our other camera started with a depth of 0, possible. I kind of like to use I like to use my additional cameras with positive values rather than 0. So I've got negative and positive. I don't have a tendency not to leave cameras on 0. It's just me. There's no reason not to. Its depth is it's just a float value that you can set to be anything. And here's our other camera. Let's move it around. And you can see already that we've got two things that are rendering. And the camera view here is only showing that cube. You can see there's the cube in front of it. There's the camera that I'm rendering. Now, if I wanted to, I could take this cube and I could add a layer. And let's put this on a user layer. Let's call this minimap layer. This cube is representing whatever your minimap is going to be. So there it is on our minimap layer. Pink. We made the layer. We now have to assign the layer. Our other camera is now going to look at nothing except for the minimap. And so there's the cube. And then if we look at our main camera, it's way over here. Yay. So remember, we've got camera and cube over there, camera over here. And we will now say it's going to look at everything except the minimap. And so now as our camera moves around, you can see that the camera, our main camera is moving in our game world. Let's just adjust our position a little bit. Now this is a bit silly because of we've got a cube here, but basic idea. So we're going to render the cube up in the corner. We could fuss with viewports and other things. You can look at viewports as well, so you can move the viewport around, which you can use for placing things. So you can share. You can actually have one half of the screen rendered by one camera, one half of the screen rendered by another camera. So now we've got our game world camera that's moving through the game world. And we can see that we have our second camera that's rendering that cube, and it's not moving. If for some reason we wanted to, frame selected, we're going to move this camera. We can see that the cube is moving. So that's that's the basic idea of how you separate two objects on two different cameras on two different layers. You can use this for UIs. You can use this for minimaps. You can use this for rear view mirrors. You could make a little object in the corner. And then you could face the camera behind you, and your car's driving along, and up here is the view of the rear view camera, which is the objects behind you. Vism asks, what is the best way to keep two game objects a specific minimum distance away from each other? I currently have a sphere collider, child objects on them, on a separate layer which only collides with itself. That does make sense. It depends how hard you want these things to stay away from each other. If you want them to be solid, a collider is not a bad idea because you bump into the collider. Another way of doing things is using a ray cast. You can cast a ray between the two objects, or one object and the other object, and find out how close it is. If you wanted to do something in a more soft manner, I would suggest that you take a look at Matt Shell's creating a hover car, because this pushes off against the ground geometry, and there's and look at the scripts that you have there. So if you wanted soft forces where two objects come towards each other and they start pushing each other away, look at using the forces that have been done in the hovercraft to push them back to another location. So you could have things that are coming too close, and the more they come too close, the more force they push each other away with. And you need to balance that within your game to make sure it acts the way that you want them to. If you want two things to come close together and not come any closer, you either use that same raycast and set its position, hard set its position manually, or you might want to use that, as you said, large colliders that only bump into each other. Spaceman Spiff, without any vowels, has very simply summed up my long and lugubrious answer. Just take a difference of the two objects' positions and set them by hand. Yeah, you need, but also don't forget, you need to balance all of that to make sure it looks correct in your game. I would have a tendency to use colliders last. I'm seeing that several people are making comments, and colliders are possible. I would try to use raycasts and testing The other thing you can do is just get a reference, as Spaceman Spiff is suggesting, get a reference to the other transform, and then you don't need to raycast it. You just simply need to compare the positions of the transforms of the two objects, and you can get an idea how close they are with each other, as long as it is purely distance that you are worried about. The question from King Jake is, what is the way that Unity's time.delta time is built? Let me bring that up. Let's look at time. It's a bunch of times. Delta time is the time in seconds it took to complete the last frame. So essentially it's just a single number of what it took to complete the last frame. And if let's just actually take a look at this. So if we wrote, made a new C# script, and delta t test. And we just simply in update said debug.log time.delta time. And then this is gonna be popped into our console. So let's bring up the console, and I do not want to collapse, not that it's gonna really help. And let's go ahead and hit play. 2 audio listeners, yes. Yeah, thank you. And I have to put that on a camera anyway. What that was is that I created 2 cameras and we've got 2 audio listeners. So we need to either remove one of the audio listeners or turn it off, because Unity can only have one fixed location for where the audio is being gathered. So let's go ahead and put that delta time tester on a cube and hit play. And we can see every frame we're getting a number. And so every frame it's taking 0.06 right there, 0.12, 0.07, 0.016. So each frame is a little bit different. My machine's doing a lot of different things. Talking to you, I'm running screen capture and screen recording and streaming stuff. So that's all affecting what's going on here. And this is simply the time it took to render the last frame. And we have that because there are certain functions that happen in update. And if you want it to be smooth, so you're moving something in update, you only want it to go as far as it should during a frame. So you need to know how long that frame took so that you know how far to move it. If you want to accumulate that, you want an accumulated time, then I would look at some of the other time functions. There is time.time, which is the time at the beginning of the frame, and this is the time in seconds since the start of the game. But time.time can be paused when you set timescale to 0. The scale at which time is passing. So you can change scale to slower and slower and slower. You can change scale to 0. Timescale at 0 is often a way that people use to pause a game. So then there is real time since startup. And this continues to count even if time.time doesn't. You've stopped time, time doesn't count up. Real time since startup will continue to count up. You can also do things like you can set how the maximum delta time before the frame basically kicks over to the next frame and does its render. Time since level load, unscaled delta time. So you can look at some of this stuff that's going on. There's a bunch of different ways that you can capture and manipulate and look at the value of time in your game. So the difference between print and debug.log, essentially it's the same thing, but print can only be done in a mono behavior, if I really remember correctly. Debug.log you can do anywhere from in any one of your scripts. But essentially they do the same thing. Also be aware that they are both computationally expensive, and you should use them when you need to find out something that's going on in your game. But you should remove them when you don't need them, because it will be printing to the log, the physical log as well, when you play the game. So if you go to play your game, it's going to be printing that debug.log into the log file, and it will slow your game down. So when you're done using your debug.logs, definitely remove them. Oh, sorry, dangling neuron. You may have missed my question and answer to you, which is that I wouldn't be approaching turrets using animation. So tell me what it is, why you're animating your turrets rather than just using physics and transform rotations. And then also the best starting tutorial that I have for using Mechanim is start with animate everything, where we animate lights and we animate doors opening and closing and that sort of thing using Mechanim. And then I'll try to get you something more if this isn't good enough. If you need some more help, forum post PM and I'll come take a look. Copperfied, my question on Raise was based on an eye to mobile development where the CPU may not be so fast. How do I best do collision detections on 200 bullets per frame? If I do 200 raycasts per frame, is it better than 200 sphere or capsule collision tests? Well, you'd have to test it out and see which is the most complicated. I would suggest that if you have 200 bullets, that you simply do 200 raycasts. 200 bullets per frame is a lot, and you may find a way to estimate or approximate what those bullets do, because if, say, you shot 200 bullets in a frame, and you're running so many frames a second, and all of those bullets are hitting in the same frame, they might be able to do some aggregate amount of damage so that you'd only need to find a single point and estimate from that point the 200 other hit points that could have happened, unless you're talking about 200 separate guns on 200 separate, say, spaceships all firing at once, in which case you may have more problems just dealing with the 200 spaceships. So I'm not quite sure of your use case, but I would first start off with just simply trying raycasts if it's too slow. So don't over-optimize to the beginning. Look at maybe doing a single capsule cast or a single sphere cast. Because remember that a sphere cast is the same as a ray cast, except you're pushing that sphere or that capsule downrange. And then say anything that is, if it's a shotgun blast, anything within that sphere is going to be hit by the shotgun blast. Then you can estimate the damage. Well, if you've got slow firing laser bolts, then your spaceship might actually want to fire GameObjects rather than raycasts, because raycasts are like a laser that's going to hit a distance in a certain amount of time. It's going to hit the same frame. It's going to travel through the distance to the target in the time it takes to make a frame, a 30th of a second, a 60th of a second. Many people are used to that with, shooting a game. You're not going to, you'll see muzzle flash and then you'll see sparks that it's hitting. But sort of that classic Star Wars laser bolt often can be very nicely simulated by throwing out a physical game object or a sprite or something along those lines that travel through space so that you can see that object moving. Yeah, if you're dealing with small rockets rather than lasers, don't worry about raycasting unless you're doing something like you're doing wire-guided missiles and you've got a target that your spaceship is trying to lock onto an object and the torpedo is aiming for that point, essentially the laser rangefinder, you won't need a raycast. MadAFK Minima, how can I test a game without repairing the internal errors without any output? No. You have to get it to be able to compile. So it has to be able to compile. Now, what you can do is remove functionality. So if you have an error in something that you're testing, I have an error. This should pop up as an error. Oh, I have to save it. Come on. Oh, I'm not in my console, I'm in my sprite editor. And so there I've got my error. And I will not be able to play. All compiler errors have to be fixed before you can go into play mode. One of the things that you can do is say, okay, I'm just going to get rid of my start value and comment that out and see if your script will compile without that value. And so now if I go into play mode, I can get into play mode because I have commented out the code. However, my offset value is not going to be correct. One of the other things you can do is that if you have a script that's causing you trouble, and in most cases this will work, you can create a new folder, and that folder is going to be called, in one word, Web Player, and then capital templates. And that is meant for scripts that you use to create a web player template, but because they are written in code, Unity will have a tendency to try to compile that web player template. So you put them in the web player templates so they don't compile, which also means that you can stick in offending scripts. Put in offending scripts, please. Thank you. And it will be removed from the compilation process. You can see we've lost our icon. It's not considered a script, and any problems could go away. But again, you're removing that functionality from your game, so you can only really use that as a method of jump-starting over a problem to solve something else, but you'll eventually have to come back and solve that problem before you can test. So Heartbreaker75 asks, what does the 1KB, 4KB texture size mean in the inspector? Does it imply that you should limit your textures to those values? I'm not quite sure what you're asking about. Let's put in a texture. And are you talking about this down here? When we're looking at images, what you can do is you can limit the max size of an object. So I can bring in a big image. Let's create a new image. And let's make this 2K. And let's get some noise in there. So I've got some noise. There's my motion blur. Yay, it's brushed steel. Whatever it is. Test PNG. Oops, where did I put it? Oh, there it is. And so there's my test, and it's really big. It's a big 2K file. Now, I can use this as a 2K file. I can actually set this at 4096, and it will not make my it's not going to make my texture any bigger. It's never going to get larger than the size that it is. We look down here, it's been imported as 2048, even though I have this set at 4K. I want this to be as big as possible. I can set it at 2K, or 2K, and again, it'll re-import, it'll go through this import, and it will be 2K. So essentially, it's never going to get any bigger. But I can choose to limit it, and when it's imported, Unity imports this. It's not going to change the actual asset. That asset is going to stay as 2K. It's going to bring it import it into the library, make some changes to it, and save it in the library without changing our asset in any way. So when it goes to the build, it'll pull from the library. So I can choose also to make this a true color, 2048, and you can see when I apply, it's going to pop up to 16 megs. But I can change this based on my target. So fine, I don't mind it being that way for the web or my downloadable standalones for Mac, Win, or Lin. I'm going to go to mobile devices, and 2K is too big. I want to make it 512 and 16 bits. And I apply. On Android, I want to override my default. Remember, my default's that's still full high res. And just as an example, no offense to Android, I want to make it 256 and compressed. And my compression quality, I want it to be fast for whatever reason. And then I can apply that. And I can do this for all of my available build targets. And this means that when I go to make my build, I don't have to worry about this texture. It's going to be built if make my build target is Mac, Win, and Lin. It's going to be a 2K texture. Web player, 2K texture. iOS, 512, 16-bit. Android, it'll be 128 and heavily compressed. And I don't have to worry about that once I've done my import. Angry Perms ask, how would I go about adding a rigid body and a velocity to a 2D sprite? Well, it depends. If that 2D sprite and that rigid body is going to be, here we go, change it from a texture to a sprite. And this sprite is going to be in a 3D game, I need to add a rigid body, and I need to add a collider, probably a 3D box collider. And then using scripting or using gravity or whatever, I'm going to get a velocity out of it. On the other hand, if this sprite is going to play in a 2D game, and I'm going to be in 2D mode, and I want to make, you know, this play out flat, I need to get a 2D rigid body, which also can be found under going to add component physics 2D, 2D rigid body, and add component physics 2D, 2D box collider. And now I'm using 2D physics. Now 2D physics is different from 3D physics. They are comparable. They are, what I say, compatible, because you can have them both in the same scene, but they don't interact with each other. So if you've got, we've got our 2D rigid body and our 2D collider, and let's take our box, sorry, 3D again, just so I can see where we are. Where's our, oh, that's right, it's the other camera. Confuse me. Too many cameras. Let's bring that back to origin. And let's bring it up. And we're going to give this a rigid body, physics 3D rigid body. And save this, and we hit play. And we can see, well, actually, they're both falling. Let's turn off the gravity on the sprite. Rigid body 2D, gravity scale of 0. And we can see that they're essentially being ignored. They're ignoring each other. The sprite is there. It's got a collider on it. The cube is there. It's fallen down onto the plane and it's stable. But they're not interacting. So they can both be in the same scene, but they're not going to interact with each other. So thanks for coming. You can follow us at Unity 3D. Follow us at the Ant Ranch. Follow us at Will Goldstone. Follow us at Matt Mirrorfish and at Mike Geig, both of which who were in the audience today. So if you have a question, post it on the forum. Post them on Answers. PM us or tweet us the URL. We'll come take a look. All right. Thanks for coming, and I will see you the next time.